Hey everyone, this week we will be continuing our Shiny series, and if you have not watched the first part, please do. The second part will look very confusing because all this code has been written. It was already in the first part, so please watch part 1 of the Shiny series. So today, what we're going to do in part 2 of the Shiny series is work with reactivity and some inputs. So first, we'll get more or less into inputs. Now, you already were shown a bit of inputs into slider inputs. Now we'll change that into more or less a select input or even a numeric input, something along those lines. So first what we'll do is we'll actually remove this slider input from what we had. And instead of saying slider input, we'll do select input. And the same thing applies as if the slider input. So you need like an input ID, and I'll just say name, and then select batter, and then our choices equals, and this is where we can use from the data set. So we go into our data frame. We see that our data frame is that statcast data, so SC. So we'll say unique SC dot player underscore name. So that means for selecting a batter, your choices will be any person who has made a plate appearance. So you'll kind of see what that looks like here shortly. But in order for that to appear on the select input side, we will need to do a bit of reactivity. And what reactivity does essentially is allows you to filter and refilter data sets based on input. So instead, we're going to remove this code that we've written for the render table function. And what we're going to do is we're going to add a reactive element. So we'll just call this SC underscore reactive. And you can add that arrow and line and say reactive. And then you do with the render table parentheses and then the bracket. And then I typically hit enter so the code is visually appealing in that kind of sense. Then what we'll do is we'll say SC piping operator dplyr filter. Again, from my last video, I did mention for some kind of functions in Shiny, highly recommend you using the package name and then the function name, just in case it gets messed up, because in the stats package there is a filter function and that works slightly differently than, say, the dplyr function. So we'll say SC dplyr filter player name equals input.name. And I'll show you what that kind of looks like shortly. But this is what we would see out of this, and we will get right into it. So essentially why we say input.name or input $name is we're filtering each time we select a player. So let's say you select Luis Robert or Fernando Tatis Jr. That reactive element filters and refilters the data set. So that way, if you do filter a data set, your data set is still kind of in the background, if that makes a little bit of sense. Your data remains in the background in the full data set. So that way, if you filter on an already filtered data set, you may not see it. So visually, you'll see just Fernando Tatis Jr. or Luis Robert if you filter by that name. Otherwise, in the background, you have that full data set. So then under the render table function, after we created that reactive element, we will say render table SC reactive and then parentheses. That parentheses just indicates, hey, this is a reactive element that will only react on what input we select. So I will show you what the code looks like in the web application. So now that we have our web application open, you can see a batter's already selected, so Dustin Garneau in this case, and data is automatically filtered to that player name. Now you can select through a drop down, or you can hit backspace and then type out a player name. So we'll go with a very popular player right now, Fernando Tatis Jr. And again, it's filtering from a large data set, so give it a second to render in this case, and now you can see you get that data. So you'll have all of this data for Fernando Tatis. Really fun stuff. So yeah, this reactive environment allows you to create something like this in the sense where when you already have a filtered data set, you can still refilter if you wanted to, say, select a different player. So if you were, say, interested in now Rafael Devers, you can pull that data from Rafael Devers. So that way you can get a filter based on the player name. So really fun stuff. And what I'll show you next is kind of a little bit more of code and adding a few more inputs, more filtering, and heck, maybe even a plot. Now what we're going to do next is we're going to re-add the slider input that we had for exit velocity. So we'll say slider input EV exit velocity. And we'll set our value to be 60, our min equals 0, and our max equals 120. So once we add that in there, we will also add that into our data or our reactive environment. So now we'll say dplyr filter player name equals input.name, and now we'll say launch speed is greater than or equal to input $EV, and our data set will also filter. But on a plot side now, since we're going to be adding a plot, I will also say plot output and just simply plot. And so we go into our output plot and we'll say render plot. Now before I get back into this, I know when I'm working with R scripts, I typically will have the libraries ready and loaded for you, but sometimes, you know, you may have a library that may pop up while you're working on code in Shiny. So what we're going to do here now is we're going to add a library called Geom MLB Stadiums. And if you haven't seen my spray charts with Mookie at Dodger Stadium, that video, that shows you what Geom MLB Stadiums package is, and it's very useful. You can plot it by stadium, so on and so forth. So what we're going to do is we're going to load that package in, and now we're going to render our plot, and I will show you how to do that. So now I've written some code for you, and I'll just explain it to you. So in the tidyverse package, there's ggplot, which is great for plotting. Highly recommend it, especially using it in Shiny. And our data set is still that reactive data set. Then AES, which is aesthetics. We're mapping aesthetics. And our HCX underscore and HCY underscore are your hit coordinates with the transformation. So I will show you how to add that MLB AM XY transformation to your StatCast data set, so that way the coordinates are accurate to the spray charts of the MLB stadiums. And then color, which is what color do you want it to be. So I have it set as events, so events like field out, single, double, triple, home run, etc. And then the Geom spray chart comes in. Don't forget the plus sign. So I know for writing some code we use the piping operator, whereas when we're in ggplot we use a plus sign to indicate, okay, hey, here's what we're going to tell what we want for the plot. And our stadium ID is the Dodgers. We're going to transform the coordinates, yes, and then all the segments of the stadium and you'll see that shortly. And then we'll remove our theme and fixed coordinates, and then our title is a paste. And what's cool about Shiny is it allows you to paste those inputs. So I essentially said paste input $name spray charts on balls greater than or equal to, and then the input of the exit velocity miles per hour. So I'll show you what that looks like shortly. Also, just so it's easier for me to scroll down and show you the plot, I just added a first 10 sample of the data set, but in the reactive environment, for us to get that XY transformation, we'll add another piping operator and just simply say MLBAM XY transformation. And we should be able to go on there. Here we are back in our Shiny web app, and now I'll select a player. So let's type in someone who's been really good this year, Brad Miller. And I only want balls that are hard hit, so 95 plus or greater. So it'll obviously give me a 10-person sample, but then down here it'll give you more or less his spray chart with the type of event it was. So double, field out, home run. Sometimes you get a no event, that's fine. Sac fly, single, and triple of hard hit balls. So really fun stuff. So thank you so much for watching. I really hope you enjoyed this. I really hope you learned something about reactivity and how certain things react to other events. So obviously if we select another player name and an exit velocity, the data set will change and filter and adjust by each different type of input that you put in. So that's very useful, as well as a plot. So this is great, adding inputs. So tune in next week. I'll work on it'll be more or less some design things to make it look like more presentable in somewhat of a case. So instead of having to scroll all the way down to see a plot, you can kind of see it side by side in a better sense. But thank you so much for watching. Really hope you enjoyed it, and I hope you have a great day.